Hello, everyone. I'm gonna say right now I'm like super excited because I figured out how to get graph paper on Explain Everything, and I googled it. It took me like 2 seconds, but I don't know why I didn't think about doing that earlier. I'm just so excited. Let me ride this high. Okay. So if you look at the announcement, there is a little quick 1-minute video I would like you to take a look at if you haven't already. So please pause if you have not done that already. And welcome back. So you will see that this unit is going to be about vectors. And something that we know about vectors is that they have both direction and magnitude. All of that stuff is mathematically correct, and I absolutely love it. Today we're going to focus on magnitude. Next video we're going to worry about direction. I'm not going to lie, we're taking a bunch of this unit and we are like cutting it down to size. So this is probably going to be a pretty short video, so please enjoy. So the first thing we need to know about vectors: what are vectors, what do they look like, what are their pieces? So I can actually use the graph paper. I'm so excited. Let's see, I'm looking at my notes, and I'm going to be skipping around on like my paper notes, so if there's some like weird pauses, just that's me looking for stuff. Okay, so let's see. This is an example of a vector. So let's call this vector V. Now, vector B is going to have 2 points. It's going to I don't know why that's happening. It's going to have point P, which we're going to call the initial point. That's kind of like the starting point you can think of. And there's also going to be kind of a point right here of Q, which we're going to call the terminal point. So you'll notice that this is essentially a ray. There's only one direction. And one of the ways that we can notate this, there's a few different ways, is that we could do P, starting point, Q, terminal point, and then we do kind of like a half arrow on top of that. You'll notice that if you take a look at the Go Formative homeworks, there's no notation for that, so you'll just see me have a blank PQ, but that is what I'm going for. So you can also say that PQ is vector V. So instead of using 2 points, you can just name it one thing, and we usually, and you can put a little arrow over B as well, we usually use U, V, or W whenever we're naming a vector. Now, someone on their test, their law of sines, law of cosines test, actually read a question about why do we use C? Because uppercase C and lowercase c look exactly the same. Why would you do this? I don't disagree, and I kind of have similar thoughts about using U versus V because they are very similar. All I ask is that if you are writing on Go Formative, please be very, very clear which you are using, or just name it W. Sometimes that's a little bit easier. But anyway, you will see me use U and V, and I will try to make that very distinct on which I'm using. So these are all the points of a vector or parts of a vector, and as promised, we can talk about magnitude. That's our first piece here, so let us talk about, and you would think the graph paper would help me write straighter, but it actually does nothing of the sort. Okay, sorry, so magnitude. Another way to say magnitude is length. So all we're really doing is looking for the length of the vector, and the way that's notated is with, it's like the absolute value sign, but with double bars. So you might see something like this. So this is the notation we could use. We can also use this notation. When you are using just a single letter, so in this case V, you can use the arrow above, but you do not have to. So for instance, you'll see in here, I don't have the arrow above. I did. With a single letter, it does not matter. Preferably when there's two, you do use the arrow, but again, you'll see on Go Formative, I don't have that because I don't know how to make that happen. If anyone can figure that out, please let me know. All right, so what does this look like? How do we find this? The equation is going to look really weird, but hopefully you've seen it before. And once we start practicing, you're going to be like, oh, this is super fast. So let's see. It moves. I'm so excited. Okay, so if we have a vector This is placed anywhere on a graph. Let's just say, all right, I'm going to call this vector v. There are points. Down here we've got x sub 1 and y sub 1. Over here we're going to call this x sub 2, y sub 2. And so we want to find what is the length of this vector v. How do we do that? Well, we can find that by turning this into a right triangle. And how lucky for us, we just did a whole unit on triangles, so we should hopefully feel very familiar with this. Now, if I am looking specifically for, where is my highlighter? There it is. If I'm looking specifically for this side right here, that is my x distance. So what I'm going to do, where's my pen? There we go. Is I'm going to take my x sub 2 and subtract my x sub 1. So that's going to give me my x distance there. And then to find my y distance, I'm going to say, okay, let's do our y2 minus y1. Now, like I said, you'll notice this is a right triangle, and something we know about right triangles is the Pythagorean theorem. So what I'm going to do is I'm going to take both these sides, square them, add them together, and that should be the same as v squared, or a squared plus b squared equals c squared. That's essentially what we have here. We're just finding the distance for each of these sides and then squaring them, however, and then adding them together. If you would like to get v by itself, or find just the length, we must square root both sides. So if I take the square root of this and do x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, that's going to give me the magnitude of v. Now what I'm hoping you might recognize is that this is actually just the distance formula, is all that it is. So if this looks a little confusing with the y2s, y1s, all of that, this is just distance formula. You can turn any vector into a right triangle and then use Pythagorean theorem. Now I know I said we weren't going to work on direction until the next video. What I meant to say is we're not going to find the direction until the next video, but I do still want to talk about direction and just kind of like what it is. So I just want to let you know that, direction is about the placement of the terminal point. So for us, that's our point Q. So for instance, if I have, here's my initial point and my terminal point is over here, this is going in the negative direction, so we can say this is negative. So if we are looking at equivalent vectors, they need two things to be the same. They need the same magnitude, which remember just means length. They also need the same direction. And the way that we determine direction is by the angle. Now again, you may be looking at this being like, why is this negative? When we start drawing vectors in an actual graph, it may make a little bit more sense. I will let you know I'm not going to require you to draw vectors just because I know that is very difficult to do on GoFormative, touchscreens, things like that. I can work with you if you want, but because of that, I will be drawing vectors so you can see, but I'm not going to require you to draw vectors. But let's start placing this on an actual graph just so that we can see it a little bit more clearly. So let's see. A vector with the initial point, so that's like your P point, on the origin, so 0, 0, is in standard position. So I might give you 2 points and ask you, what does this look like in standard position? So for instance, wow, even with grid lines, that's not a straight line at all. Well, I tried. So if I have something, here's my point P. I'm just gonna draw a real small vector. So that's vector V right there. That is in standard position. However, if I was to draw some equivalent vectors, something with the same magnitude, same direction, it may look something like this. So both these vectors, even though they're not in standard position, have the same direction, or you can think of it as like angled slope, and same magnitude, same length. So again, I'm not going to have you draw these, but I am going to have you start finding things for me. So we're just going to go through a couple practice problems together, writing vectors in standard position in component form, and we'll talk about that, as well as just finding some magnitude. So let's do that. So as I just said, standard position is written in component form. It would be helpful if I could spell the word component. It's been one of those days. That's how spelling works. Yes, okay. Component form. Now, the reason we specifically do it in component form is so that we don't confuse it for a point. So whenever we write a coordinate point, we use parentheses. Whenever we write a vector in component form, we use arrows. So you're going to see things like this. So for instance, let's draw, wow, not at all is this straight. The flat one's a little straighter. Okay. So let's see if I can follow my graph. You can maybe hear the rustle of paper. Okay, 1, 2. Okay, so this is going to be point P. This is at 5, 3. And then Q we'll put right here. And this is at 8, 5. So what I'm going to ask you to do is to put this into component form. Or what would this look like if it was, if P was at the origin, if it started there. So this is how I'm going to find it. I'm going to say that P of Q, my vector, is equal to this distance here, which we're going to find by x sub 2 minus x sub 1. And then our y value, this distance here, we're going to find that by y sub 2 minus y sub 1. So let's see, let's call our P points x sub 1, y sub 1, our Q points x sub 2, x, y sub 2. So when I plug this into my equation, finding my vector, we'll say this is 8 minus 5, comma, 5 minus 3, or the vector of 3, 2. So what we can really say is that P of Q is 3, comma 2 if we were to put this in standard position in component form, or it's already in component form if we were to put this in standard position. And what this really is, this is just the x and y values that we're going to graph. So if I put this here, it's going to go to there. And there's that new vector. So that's all that we need to do there. And if I asked, hey, what's the magnitude, or what's the length of that, I'm going to plug this into my equation and solve. I can make this into a right triangle and say if I want to find the magnitude of PQ, that's going to be the square root of my, and you've already done your differences, so this will just be of 3 squared plus 2 squared. It'll be the square root of 9 plus 4. And we're just going to leave this in square root form. Please do not plug this into a calculator. Oh, this is going to get a little bit messy. So we can say the magnitude of PQ is square root of 13. And this is all I want you to get from this lesson. Like I said, short lesson. You have given 2 points, found your standard position vector, and then you've also found the magnitude. Next lesson, we're going to be working on direction and adding and subtracting vectors. That's it for this unit. I'm going to do one more example with you, and then we're done. So a lot of this could be very visual if you want to draw the vectors. However, if you do not want to draw them, this is what it might look like. So for our next example, I'm going to just say, okay. I'm going to tell you that point P is this point right here. Q is this point right here. So if you would like to draw these points, you completely can find things that way. Or if you prefer to just do things algebraically, we can say, okay, we know that PQ is x sub 2 minus x sub 1 y sub 2 minus y sub 1. Your p's are always going to be your sub 1s, and your q's are always going to be your sub 2s. So when I go through this, we can say that p of q is just, these are the notes I don't have written down that I'm doing on the fly. Let's see, this will be 5 minus 1 and 6 minus 2, also known. So let's see, p sub q is 4, 4. Okay, so that is our vector in standard position in component form. Now that we found that, let's find the magnitude. Remember, these are just our x and our y value from our standard position. So my x value side length is 4, my y value side length is 4. So we can say that c squared is equal to 4 squared plus 4 squared, or that the magnitude of vector PQ is the square root of 4 squared plus 4 squared, or the square root of 16 plus 16, or that the complete magnitude is the square root of 32. Don't have to simplify it, just leave it there. So these are the answers I'm looking for. There is my magnitude. There's my vector. And that's all that I have for this video. So if you have any questions, please let me know.